Okay. Uh, Now we are going to talk about the domain on fractional function that has radical in it. Okay, I give you two examples here. See, when you have a radical function with, like this one, you have to set what is under radical to 0. Okay, I will tell you why. Is equal is no, larger. This should be, this must be actually greater or equal to 0. It can be minus, we can't be like minus 15. We can't have that because this is a different story. Imaginary numbers. Now, I tell you why is like that. Okay, what we're going to do to find the value of x, you know that minus 3x, this one is going to go up here, the other side, minus 15. Now you dividing both sides by minus 3. See, when you divide by the minus, you multiply by minus, then the sign is going to change. But in regular things, when you have 3x larger or equal to 15, for example, this is positive. So what you do, you just say x greater or equal to 15 over 3 is equal to 5. But this is negative, so the sign is going to change. So what is going to happen here is going to be x less or equal, less than or equal to 15 minus 3 is going to be 5. So we find the equation. See, the equation means that you find the value of x, where x, intercept the function intercept the x-axis. Now here, it looks like this. If you put it in the calculator, as you know that if you use calculator here, so what we do is you write the equation here. See, is minus 3x plus 15. And then you push this one and it graph for you. See what it's trying to say, this is where intercept is like this. So what does that mean? We talked about that earlier, but I'm going to go further up and use the fractional function that involves the radicals. See, what's going to happen, what it's talking about here, you can give all the value from minus infinity to 5, plus 5, and included 5. You can have answer for f of x or y. This is f of x, and this is x. You give value to x, find f of x. Like here. You can find the equation, we say what is going to be 2, what is going to be 2. For example, x is 2. You can find that y, if it is 2, this minus 6 plus 15 is going to be 9. Square root of 9 is going to be 3. So y f of x is going to be 3. You can find any number here, to find you give the x value here is minus part of the, so you give value. So what it means here that you only can give value to x which is located from minus infinity to up 5. You cannot give any number over 5 because it's not in the domain of that function. See, what is happening here, that the domain of this function is from minus infinity to plus 5 and included 5, because you can put 5 in there too, because if you can put minus 3 times 5 plus 15 is equal to minus 15 plus 15 is equal to 0. So if it's x is if it's 5, y is going to be 0, because you know in these two x and y axis, you know, this point is 0 0 0 0. When the point located here, the x is like here is 5 and we don't have y is just 0. Okay, let's go further up. So the domain is going to be from minus infinity to 5. Like this example, this is the same thing, but we don't have the minus sign. See, the domain is going to be, if we set this one, see, under the radical is always got to be a greater or equal to 0. So it cannot be negative under the radical. So what we do, we find out value of x. X is greater or equal to 5. So this is the function. This is the graph of this function. So what is the domain? Domain is the value of x can get. See, this is x-axis. The value of x started from 5 and included 5, because if not included 5, you use just parentheses. But when it included 5, you use this bracket, a square bracket. So I was just trying to tell you, you know, in general, you cannot give any value to less than 5, because if you give less than 5, it's like 2, it's going to be 3 times 2 is minus 15, it's going to be 6 minus 15, it's going to be minus 9, and you can have negative number here, you know, the radical, square root, that's imaginary number, that we, you know, in some measure they have a lot of use for that. Okay, let's talk about some function that like this one. F of x is equal to x plus 2 over x minus 4. See, at this one you got to you want to find the domain of this. Okay, see, at that time the function was like this, you know, f of x radical whatever it is, 3x plus 2, you know, whatever it is. But here now is in denominator. Here was a numerator and denominator was 1. But here is in denominator. Means here the whole thing it cannot be 0, because, you know, if for example you give value to x like 2 and then the denominator is 0, 2 divided by 0 is going to be infinity. You know, so you don't want this one, the result of this one, whatever it is, like, you know, it's not going to be 0. So what we do, we say x minus, in regular way, we say 3x plus 2, it must be greater or 0, greater or equal to 0. But here we can only say it got to be greater than 0. Because if it is equal to 0, then the number divided by 0 is going to be infinity. And we don't want that. So, what is under the radical is greater than 0? X is greater than 4. So what is going to happen? I mean, let me show it to you. The domain of this function x, the domain of f of x, is going to be equal to, see, is greater than 4. Any number that, see, you remember that? X, y, Like this is 4, okay? 1, 2, 3, 4, or here is negative number, or here, we're talking about this one. It's greater than 4. Means any number greater than 4, not 4. So actually it's going to be like this. Greater than 4. Whatever the number is greater than 4, it could be billions of numbers, you know. Even we have billions of numbers from 0 to 1. From 0 to 1, you can have billions of these numbers. You know, here is 1. See? We can have 0.0001. We can have 0.00000020. You just up to getting to 1. It's billions of, I mean, infinite number of numbers. Infinite. So what I'm trying to say now is, if you want to write the domain of this one, it's going to be greater than 4. So 4, this is not included. The parentheses is not included. This is going to be like this. The domain is started from 4 and go to infinity. So when you see something like that, the denominator cannot be 0. Okay, let's find. We are not talking about domain right now. We are just talking about domain. Let's talk about something else here. The radical, it should be numerator and denominator is going to be let's say x plus 4. Okay. What is going to be? Sometimes when you have two, what is going to be the answer for this? Okay, we say that we said x plus 2 got to be larger or equal to 0. So x is got to be larger than minus 2. X is got to be larger than minus 2. And then x here, if we set it is equal to 0, if it is 0, x is equal to minus 4. I mean, the minus 4 cannot be. See, we got to exclude minus 4. Okay, all the numbers that minus 2. No, let me first, whatever I was doing that, because I use this one as a, let's, my original question was like this, that because then that was another question that I was going through, but anyway, see what you do, minus x plus 5 is equal to 0, we say that it shouldn't be 0, but we find that x is equal to 5. Okay, what it means here, that all the number larger than minus 2 except 5. See, as you know, that here is minus 1, minus 2, minus 3. See here, and the plus 1, plus 2, plus 3, 4, you know, it, like here is 5. X is equal to 5. See, is larger, greater than minus 2. Means all the number here, see here, is less than minus 2. Because the number is decreasing, you know, like -4, -5, you know, all these numbers is less than -2, you know, as you go, it's decreasing. So what it say? You get all the numbers that greater than -2 here, all these numbers. But it say that when the denominator cannot be 0, the denominator cannot be 0, because if this one is 0, the number divided by 0 is going to be what? Infinity. So we never want to, we have the denominator 0. So we say that all the number here, we say like, let me write the domain. The domain is -2 to 5. From -2 to 5, okay? Not included 5. And then we have the union of this, okay? From 5 to infinity, because not 5 doesn't include, so 5 to infinity. See, cannot be 5. Look, let's draw this to see what it looked like. What it looked like, you know. We want to write the. Let me. Oh. Anyway, there is not enough light. Okay. Anyway, so let's see what it looked like. We write this a square root of x plus 2, then divided by parentheses minus x plus 5. See how what it looked like. See here. Actually, it shows the 5. See, it look like this. Okay, we can bring it closer. And you know, you can use window. See here, it says that at 5, it gets something like this. It's not gonna 5. And then it's gonna be like this. Mean at 5, it's gonna be infinity. So this is not gonna get to the 5. It's approach 5 at infinity maybe. Yeah, it will infinity. So what it shows like this, okay? So we talked about one in the denominator, the square, the radical function, and one in the denominator and one in the numerator. Let's find a lot of other So, so the last one we were talking about, this one was how much? X plus 2 was minus x plus 5. See, so the domain, I don't know if I write the domain or not, but the domain is going to be minus 2 up to 5, and then the union of 5 to, I think I wrote it down before. So I just want to tell you that was the domain of this one. That include 2, minus 2, larger than minus 2. See? You see that it started from here up to 5. This is 5, and then so it cannot get to 5. So it won't get to 5. From 5 to, see, this is minus x, from minus infinity to plus infinity. So let's talk about this interesting another example. That just the radical, the square root, x minus 3. Okay. What we do, we say that under the radical it can't be 0. For x minus 3 is greater or equal to 0. It cannot be less than 0, because negative number cannot be. So what we do, see here, you're gonna use this logic that this is a positive number, and this should be a positive number, so it could be greater or equal to 0. If this was a negative number, so a positive number divided by negative number is going to be a negative, so it's going to be less than 0. But we assume that the whole thing is going to be greater or equal to 0. So what we do, we say x minus 3, it got to be greater than 0. It's going to be positive. It means whatever we say is greater than some 0, it means it's positive. So x greater than 3, you know, x is greater than 3. So how we show it here? It's 1, 2, 3 is greater than, means it's like this, whatever the graph. So if we graph this one, see, always try to graph this kind of function that is hard to, imagine what they look like. So use this one at x to use the radical square root 4 divided by x minus 3, and then so what? See, it says like this. This is not gonna get to 3. So so what is the domain of this? The domain, it say that is greater than 3. Okay, it's greater than 3. Open circle. it's not filled. So it's going to be the domain of this function is going to be equal to 3 up to infinity. Whatever is larger than 3. You know, you can give any value larger than 3, but you cannot give this value because, you know, if you give x value, you cannot find the y value for that. That's why, you know, it's like this. So let's, there are a few more examples. F of x is equal to minus 9 radical x plus 3. See, we know that x plus 3 got to be under the radical, it's got to be greater or equal to 0, but it's located on the denominator, so it cannot be 0, so it can be only larger than 0. So x is going to be greater than minus 3, okay? So so the domain of this one is greater than minus 3, means here 1, 2, 3, minus 3 is going to be greater than this one. It's going to be going this way, you know. So the domain is minus 3, greater than minus 3 up to it plus infinity. But it was equal to 0. Suppose that it was equal, greater or equal to 0. This could be a bracket, minus 3 to infinity, because it included the infinity minus 3. It greater or equal minus 3, it looks like this, but it's just greater than minus 3 is going to be like that. Okay. You know that just before finishing this part of the you know that if we want, I don't know if it's enough time, if minus 1, for example. If you want to find the vertical asymptote, see, you just set this one to 0. The denominator, see, it's going to be x to minus 1. It's minus 1 here. See, the vertical asymptote is going to be like this. And when you try to graph it, I think we won't have time to. We talked about that earlier. It